whether you call it Taramps or Taramps. In today's one, we're going to be checking out the newest offering on the Big Boss lineup, the Taramps Big Boss 3K. I mean, just look at the size of it. This thing is absolutely tiny. And from what I've heard, this thing also does decent power. So we're going to verify this in today's video, and we're going to look at this amplifier, dyno test it, show the insides, and let's see what this is all about. Looking around the amplifier at the front, back, I don't know where you would call it. Yeah, it's right. So on the right hand side, now on the left hand side, we have in, out, gain, high pass, low pass, frequency, bass boost. Just get a bit of a Sharpie, just rub over that. Don't need that. You got your connector here for if you have one of these. These are pretty cool. I like how they're not like notched. It's just smooth all the way out. I like that. And then obviously on the remote you have the clip on, protect. Then you have your speaker terminals, positive, minus. And then on the other side of the amplifier you have two fans with their smart cooler technology that they call it. And then you have your positive, negative, and remote in the middle. And then on the top of the amplifier we have the Taramps logo, the Big Boss 3 bass, and the 3 will light up either white, yellow, or red. And then you have your LEDs here that will light up. You can have VU meter, so you can have the lights showing the music input and all of that. Shows you when you're clipping, which is really nice. And then you do have this warning right here, this heat warning, which is what I'm gonna show you guys further into the video. Okay, so let's get this opened up and flipped around. What we got here? Philips. All right, on the other ones, they're normally Torx, but this is easier for me because I do not know where my Torx set would have been, but nice. This panel should now be free, so we could just pop this off and have a look inside. So here is a look inside of the Taramps Big Boss 3K. You've got your power supply on the left, output section on the right, transformers, inductors, 160 volt capacitors. So we got decent rail voltage on this, and it looks fairly well done. It looks like they've taken care. Nice solder work. Looks really cool, to be honest. Nice and clean. One thing I don't like about what Taramps uses are these pots. I'm not a fan of these pots. They feel too cheap. I would have just liked normal ones that just turn. I don't understand, like, all of this. What's all this all about? Yeah, not a fan of that. But apart from that, she's good. If you look closely here as well, you can see that it shares the same PCB. So we've got the Big Boss, got the HD series, and the base series. That is pretty cool. So they're utilizing the same board and just populating it with different components. The cooling in this amp draws air in from here and blows it out this way over the components, and it exhausts out here. It's pretty effective. When I'm running this amplifier, I do feel some temperatures coming out the back of this. Well, I say the back, but it's technically the side. So that's the inside of the Big Boss 3K. Now, does it do its rated power? It's pretty easy for this one with Taramps smart technology. We have 3000 watt at 2 ohm, 3000 watt at 1 ohm, and 3000 watt at 0.5. And at 4 ohm, it should do 1700 watt. Let's see if it lives up to that. We are going to be testing it at 15.8. The numbers it got here were at 14.4, but the maximum supply is 17 volt DC, and we're going to obviously give it 15.8 volt DC, but that will drop as you start to pull current. You're probably wondering, how am I going to power the Big Boss 3K in the house and do the dyno test? So we have power supply. We have many of these power supplies if we need them or not. Right now we're only using one because one is more than enough, and this is charging at 15.8 this bank of lithium. So you can see 15.8. We've got this U charge here, but the thing is with this, it floats and charges at different rates, so we can't share it together. So that's that. How I'm going to load the amplifier is we have 8 4-ohm resistors connected to this distribution panel here. that is also connected to XT60s. It's long, but it works. Unplugging these will increase the resistance, and then plugging them all back in will decrease the resistance. So I can choose what resistance I want just by unplugging or plugging in a certain amount. We also have these cables here. This will go for this is for the SMD meter, so that will go on the top here. Got some wire for the speaker, or to act like a speaker. This will plug straight in from the resistors into your amplifier, and I just loop it through here. Also, I put my oscilloscope probes on these two here so I can get some sine waves going. All I've got to do now is get the amp on the table, connect it up to the power supply, and we're good to go. Also, I know I'm going to get comments. Why is it on wood? Bear with me. Let me explain. Where there is so many resistors, yeah, and where my dyno runs are so short, the hottest these have gotten while playing the Big Boss 3K for about half an hour was 70 degrees Celsius. Not hot enough to do any damage. In today's video, it won't even get as hot as that, as we're only going to do strictly just dyno runs. So these will probably only see 40 to 50 degrees because the heat is distributed throughout all of them. So there's plenty of surface area for the heat to disperse. Plus, I don't really know how effective this fan is, but it is here. Okay, be very kind to me, please. Be very nice. Wait, let me check out if you got this connected right. Okay. Negative. Yes, confirmed. To negative here. Okay. Yeah, she got... okay. You guys don't notice? No fuse, gang. Come on. Look at that. See that? If it blows up, see me? I'm heading out. Touch wood. The new range of Big Boss series have been pretty reliable to me. I've had the Big Boss 8K and the Big Boss 3K, and I've clipped the absolute hell out of them. And they've always just gone into protect, or, you know, just told me, chill. You know, chill out. Calm yourself down. So this should be fine. That if any problem happens, it should just protect. So we'll just connect up the speaker wires, even though it's not going to a speaker. I've tricked the amp. The amp's being fooled, but it's cool. I apologize. My bad. So we plug the 3.5 into here, and then we have this Bluetooth receiver, so I can stand outside the house when I do my test. Great stuff. I can stand well back, press that from a distance. Cool. Right, now oscilloscope, get that connected, and then we are good to go. Oh, I lied. I need RCAs, don't I? I've done that so many times. I've gone to play the amp. I'm like, why is it not working? And I look and it's like, oh yeah, that would probably be why. I can't seem to find my probes for the oscilloscope. Nope, it's not in there. Of course, it's right in front of me. Thank you very much. Put that one on there like that, and then we put this one on here like that, and now we can have an insight on visually what's going on with the sine wave. Right, let's turn the fans off, because this is probably not the best way to turn off the power supply. Off. Right, there we go, peace and quiet. I can now show you guys and let you guys hear the startup process and see the nice beautiful lights. So take this remote wire and I can just connect it to the 12 volt here. I have like this little thing here, just shove it underneath here, and then we do that, and it screams at you, then lets you know everything's good. And yeah, you got all the lights here. In fact, let me turn off this light. Let me show you a bit more. Hold up, 2 seconds, guys. There we go. So yeah, you have all the lights, changed them. It's pretty sick. I do like the RGB. Personally, I probably won't use it. I'll probably leave it just on the standard. It's gonna let me do it. Nope, not that one. Nope. See that? That's me. That's the bit of me that is stealth. Just let me see when it's clipping. Just number 3. If I'm at a show or something, which, yeah, just. The nice thing about this amplifier as well is when the fans are not needed, the fans are not on. So when it's idling and there's no heat in there, the fans will stay off. When you play some music and a bit of heat starts building up, the fans will go on. But not full blast, they go up in stages. It will it's regulated. If it needs more cooling, it will give more cooling. It needs less cooling, it will give less cooling. For the fun part now, let's see if this amplifier does its rated power. We're going to start off at 4 ohms. It's rated 1700 watt 4 ohms. So I'm going to wire up the resistors, get it ready, and we'll do the 4 ohm test. We are looking for 1700 watt at 4 ohm. Do we get it? This should be no clip. The light should stay off. That should stay white. If it's clipping, it will go yellow. And if it's really badly clipping, it will turn red. Let's go for it. Wow, 1800 watt at 4 ohm, and it's at 4.2 as well, and we still got more. That is impressive. Now we're going to do clipped, so we're going to turn this up like 3, and we'll set it again. Do we get more than the 1800 watt that we got clipping though? There you go, 1897 watt. The fans come on, you saw the lights go yellow, then red on the clipping. Cool. Cool, so now we'll do some 40 hertz burst. See if we've got any dynamic headroom at 4 ohm. $16.82. Oh, 1740. 1856. Okay, now we'll do the same test again, but we'll clip it on dynamic. So we're now going to clip it. Let's see what we get. $19.62. And you can see that is squaring off pretty badly. This is now the 2 ohm test before clip. Do we get 3? So it's rated 3000 watt, but we are on the other side of smart by 0.1, so I don't expect it to maybe hit the 3000 because we are 0.1 above smart. So let's have a look. So we didn't quite hit 3000 because we are 0.1 above a smart, like I just said, but we got 2620. Let's clip it now and see if we can make the 3K. So same test again, but clipped. Oh, red, damn. But we made the 3000 watt, but she was getting angry. 40 hertz burst. Did we get 3000 watt on the burst with no clip? So we're not clipping, but it's still not 3000 watt. We got 2831, not clipped, but still not the 3K. But again, we are on the other side of smart by 0.1. So again, we will turn up by, I did 3 last time, didn't I? So I'll do 3 again, reset the meter, and let's go through it again. Do we get 3000 watt clipped burst? There we go, but look at that wave. $3,281 watt clipped. For the 1 ohm test, do we get 3000 watt on the clip? So it's rated 3000 watt. Yes, we did 3301 watt. And no lights come on. Pretty nice. You can see the limiter circuit again, but the waveform is still in shape. Nice. So we'll turn up 3 times now to go to like push the amplifier past where it clips. But now where it's wired to 1 ohm, we shouldn't really be touching the tops of the rail voltage because of the impedance. However, you should start to see the limiter circuit kicking in now, where you will start seeing wobbling where it's bouncing off it. So do we get more than 3,000 watt? And this is the smart you're going to see now, how cool it is. It's really cool. There you go, you see the wobbling? That is the limiter circuit. 3,799 watt. Crazy. So this is 40 hertz burst under clipping. Do we get more than 3,000 watt? Wow, 3,900. 3,982. That is crazy. Nearly 4,000 watts dynamically. Now we'll do it where it's going to be showing clip on the amplifier. Let's have a look. Wow, look at that waveform. Damn. That can't be good for the amp. Poor amp. But 4,718 watt. My God. So what you were seeing there, where sometimes it was a perfect sine wave and then you saw the spike, like it was changing, is sometimes the limiter circuit was catching on to the current and sometimes it managed to get through where the circuit couldn't activate quick enough. That's why I was getting these high numbers. Very interesting. Here's the 0.5 ohm test. Do we get 3,000 watt? $3,385 watt. So yes, we do. Now we'll push the amplifier just a little bit more. Do we get more than the 3,300 we just got? Oh, she did not like that at all. As you see, the protection on point. It is brilliant. It is absolutely brilliant. But yeah, 3,556. For those that are wondering how my voltage is holding up as well when I'm doing these tests, this is what we're dropping to. So I'll run you here, just here as we stop climbing, and I'll point you down here now. And this is what we drop to. $14,600, and we got 3,475. So yeah, she's good. So this is the 0.5 dynamic burst at 40 hertz. What do we get? You see that? Sometimes it's a nice sound wave, sometimes it's like that. That's the circuit kicking in. But 5,286. Crazy. And we're not done yet. We're just gonna go to 2 more clicks. Damn. That is crazy, man. Right, I'm gonna stop that. I'm gonna stop it. Oh my God. That is ridiculous. 6,785. I know it's smart and it's intermittent power, but still, the fact that it did exist and it was there is crazy. This little amplifier is absolutely insane. It is a small amplifier and it's doing big boy numbers like that. Regardless of the smart, even still, it's doing 3,000 watt. This amp does 3K and it's tiny. It's ridiculous. It's crazy. And look, it survived. It didn't break. I'm pushed this amplifier well beyond its limits that it should be doing. I don't know what to say. Like, it's crazy, man. It's really cool. What we're going to do is we're going to do a 0.5 ohm endurance test to show you thermals of how hot this amp will get. So we'll play a song. You're not going to hear the song, but you'll see the sine wave. I'm going to fast forward it so I don't bore you guys, and then I'll show you the temperature and why we do have the temperature warning on it, because she can get toasty. Bear in mind, I'm at 0.5. This is worst case scenario. This is where the most current will ever run through this amp. Obviously, when you connect to speaker, you have rise, less current. But this is going to be the worst case scenario, exactly 0.5. How the hottest, technically, this amp should get playing music through it for an extended period of time. So I've got a temperature gun. I'm going to play a song for it for about, I'll play the whole song for it. And at the end, I'll fast forward it and we'll see how hot it got as a worst case scenario on the thermals. So I'm just going to stop that there. As you see, she is very hot. And I don't really want to break this amp. But you see, that is why there is that symbol on there, because it can get very hot. 80 degrees is very hot. And I thought I should stop the test because I don't want to find out if it's got a thermal protection in it, and I don't want to find out the hard way and break it. But as you see, it can get very hot. But that's worst case scenario. So, yeah. And here you are, guys. Remember I told you how these don't get too hot because of the dissipation of all of them? See? Very good. Wow, what can I say, man? This is an amazing amplifier that definitely packs a punch. It's brilliant. It's small, it's powerful, and it's a fun little amplifier. Like, I don't know what else to say. Like, well done to Taramps for building something so small that performs. It's amazing. But yeah, guys, if you enjoyed this one, make sure to leave a comment, like if you liked it, and tell me what other amps you want to see. And I'll catch you guys in the next one.